This is the Form 1. This is another 3D printing machine we have at the foundry. And this uses an SLA, the laser curing process. We'll play a little video here. We'll turn the audio off. And because it cures in liquid with a laser rather than extruding molten plastic out of a filament, you can get much higher resolution shapes. You can get very prettier things, more retail-ready looking products. It's a little bit slower, it's a little bit more complicated to use because you have to deal with a very clean liquid. It's a more sensitive device, but it can create some amazing things. And even though there is the object emerges from liquid as the laser is tracing the shape through it, you still need to add support structure, these little ligands that hold very broad and flat shapes together. So this person is making a floral design, and those petals are long and flat, so they need some support structure to hold them up, and when you're done you just snip it off and sand it down. The software will help you to create that support structure automatically based on the curves and flatness of the shape. And you can see there are different pliabilities, different strengths to these kinds of machines, different resins you can use to print very hard engineering components, much more intricate jewelry kind of components, which you can then make molds from and cast in metal. Very pliable and strong parts. Really fun tech. And here we have the Form 1 SLA printed part versus a fused deposition printed component. So you can see again some of the differences between a part that's been made with the hot glue gun for plastic, as it were, versus the SLA process. So we've gone over some very broad brush overviews of how a laser cutter can cut plastic or wood, how a 3D printer can make objects out of thin air. Now, how do you make those digital files that serve as the input for these things? For 2D design, we like Inkscape. Inkscape is a great program. There are a host of others, and we'll have a list of all those tools at the end of this presentation. But Inkscape, let's go back here, make sure my audio is off. Inkscape is essentially a free version of something like Adobe Illustrator. It allows you to draw on the computer with your mouse, and I know that Linda from lynda.com describes drawing with a mouse kind of like drawing with a bar of soap. So some people prefer a stylus, much closer to a pencil or a pen, and we have a couple of stylus tablets at the shop too. But what I like about drawing on a computer is that if you make a mistake, you can just undo. You can move and nudge it. It's a much more flexible medium than just drawing with a pen and paper or pencil and paper. And you can either draw directly in a vector format like this, and those vectors again can be the paths that a laser will follow to cut plastic or to cut wood, or as we'll show later, you can import a JPEG, a photograph, and you can convert that into a vector file that you can then send to a laser cutter. So here again, a laser will cut along the vector lines, but if you have a grayscale or color photograph, it will etch or engrave, essentially print an image into plastic or wood based on that photograph. So download Inkscape, watch a few YouTube tutorials, learn, become comfortable with it, and you'll be able to make things with a laser. So the difference between a bitmap, which is something like a JPEG, versus a vector, which is essentially line art, is the following. Here we can see on the left, if you zoom in on a JPEG, eventually you'll see the pixels that comprise the photo. But a vector is just the straight lines that define the elements of an image. So if we were to look at the difference between a vector and a JPEG or a bitmap, you can see the vector is comprised of those blue lines that we saw earlier versus the pixels of a bitmap. Now you can either, if you have a bitmap, you can either trace by hand, manually or with a computer, all of those shapes, or there are softwares that will automatically create vectors based on those bitmaps, and we'll talk about how to do that. So 3D design is a little bit more complicated. We can do things like 3D scan a shape that you've made by hand, so imagine Play-Doh or paper mache or other media. or we can create a 3D design and we can slice it in a couple of different ways to use a laser cutter to build up a 3D shape, and we'll talk a bit about that in a second. One of our favorite 3D design programs is called Tinkercad. Even though it sounds like a kind of Fisher-Price childish tool, it's a really powerful design tool. It's a through-the-web app, so you can run this in Chrome or Firefox. And what I love about it is that you have these geometric shapes that you can just click and drag. And if you can click and drag one of these shapes onto your grid, you can add more shapes to them, you can scale them. You can even use these shapes to subtract from an existing shape. So for example, this person is making a chess piece in the form of a little handsaw. So they've taken the rectangle box icon, they dragged that out, then they took what they call the roof, which is a triangular prism, and subtracted out this side here. And clearly this is time-lapse, clearly this is sped up, but you can see how this person is using these canonical shapes or these example shapes, clicking, dragging, moving, rotating, positioning, and then adding and subtracting to create a 3D shape. So you don't really need to make, in traditional CAD sense, datum planes or radius sweeps or vertices or lines. This is a much more intuitive way to create a 3D geometry. And just like in Microsoft Word, if you have multiple photos or objects, you can group them and move them all together. Here you can see that this fellow has taken those roofs, copied a bunch, aligned them all together, grouped them, and moved them as essentially a digital sculpting tool to bite out that piece of that gray center part to make it look like the teeth of a saw. And then they're combining what they call the round roof with another box to create a shape that they're going to slide into the wooden block on the top to use to subtract out a shape, which is where your hands would go if you're holding that saw. And again, once it's grouped, you can easily scale it, position it, rotate it, move it around. So you can see this is a super powerful, super easy way to create 3D shapes. And then we can take these 3D shapes and we can either 3D print them or we can slice them into sections that we can then separately laser cut and stack together. We'll talk about that in a bit. So again, go to the web, open up your browser, find Tinkercad, and play through the web. You can even save your objects to the cloud this way too. I'm going to skip ahead to see what this part looks like at the end. There we go. That's a cool little chess piece shaped like a saw. Now, you don't need to create things from whole cloth. There's a great repository of legally free, downloadable solid objects, and solid objects are what we call these 3D shapes that you can then 3D print or laser cut. So here, there are plenty of iPhone cases or phone cases that are already readily available. So you can just download it, open it up in Tinkercad, and then edit it. Like I said, I think one of the fastest ways to add value cost effectively is to take a mass manufactured device or product and then customize it yourself. Let's call that a mass manufactured digital device as well. So if someone has already gone to the trouble of making a wearable wristband or an iPhone case or an Android case, then just take that, if it's legally available and distributable, then take that and modify that. This example is one of my favorite examples of quickly adding value to something. This person took a legally available and distributable 3D shape, a phone case, and then this person likes falcons. So they just Googled the word falcon in Google Images, and I learned something here. I learned that there's a type option for Google Images, and if you choose line drawing, then it will limit all the sections or all the selections you find to line art. And again, line art is close to a vector, and that's the kind of file format we need for a laser. Equally, you could type in falcon space vector, or even better yet, falcon space SVG, which is a type of vector file format, and get the same kind of limit, but you might get a few better selections if you add line drawing. You'll find some more options. So here, these are all the options that came up when this person chose line drawing for the Falcon image search. And they found a superhero named Falcon, and they especially liked this guy. So they downloaded this image and then uploaded it to a free conversion app that can take a bitmap, that is again a JPEG or an image, and convert it into a vector. And that vector is, again, what we need to give the laser. So they uploaded that image, converted the bitmap into a vector, downloaded the vector, and imported it into Tinkercad. Now notice a really interesting and useful thing here. If you import a two-dimensional flat vector, Tinkercad can automatically add some depth to it. So the default here is to add 10 millimeters, or to make it a centimeter thick. So instantly you have a thick 3D object. And you can scale that, you can move it, and we'll watch what this person does in this regard. So here, again, just like manipulating a photo or a line art image in Microsoft Word or some other simple editing software, you can move it, you can grab it, let's skip ahead a bit here, scale it and position it. And so this person is moving it to a spot on the phone that they like. And then what you can do, in the same way that you can subtract out a box or a cylinder or a roof from a 3D object that you created from whole cloth in Tinkercad, you can subtract out this shape from your existing object and create an engraved phone case, or you can add it underneath it and create a kind of embossed or raised image. So here this person, I'm going to skip ahead a bit, is pulling it through the phone case. Clearly 10 millimeters is too thick. This phone case is probably only a millimeter or two thick. So they're scaling the Falcon 3D shape to be a little bit thinner than the phone case here, and then they're subtracting it out. So I'm going to skip ahead a little bit here, and you can see that once they've subtracted it out from the broad flat base of the phone case, then you're left with a 3D object that has that image effectively embossed into it or engraved into it. Then you can 3D print this shape, and you have a 3D printable phone case which might only take half an hour or an hour to print, because it's very flat and short. But you've added a lot of value, added this custom, really interesting design. Notice that clearly was time-lapsed when this person was doing this work, but it's probably not much more than 5 or 10 minutes of effort from downloading a shape from Thingiverse, which is a great website. GrabCAD is another website where you can get legally free downloadable 3D shapes. Then you can take an image that you've created or modified. Again, make sure it's legally distributable, but you can easily search it, find it, convert it from a JPEG into a vector, import that vector into Tinkercad, give it some depth, move it, scale it, position it, rotate it, and then subtract it out or add it to that 3D shape, and you've made a whole new image. Essentially, it's the equivalent of taking, in Photoshop, cutting your head off and putting it on somebody else's body. It's pretty easy to do in Photoshop. Increasingly, this is getting easier to do for 3D design. And that's a great thing because we've got machines that can make things for us out of 3D now. So another great software program that allows you to design in 3D is Sculptris. It's a free software program, and essentially you see a ball of clay on the computer, and wherever you drag the mouse, it either removes material or adds material, extrudes, stretches, or compresses. So again, this is time-lapsed, but you can see that if you're a talented 10-year-old with a good eye and some patience, you can create the 3D file very intuitively that you can then send to a 3D printer, or then slice and send to a laser cutter, so the laser cutter can cut those sections and you can stack them together.